Alright, welcome back to the video presentation for my project and internship. Last time we talked about filtration of common materials, kind of the basics of how masks worked, and yes, that is part of my project because it all started with COVID, with proving that 3D printing parts is food safe. All does relate back to viruses, bacteria, surface tension, and everything we discussed. All of that stuff is preliminary to testing for food safety. So they go hand in hand. And you saw some maths. It was kind of cool, kind of interesting. And now we're on the preliminary testing of the 3D printed parts. And we just did surface and gap testing where I swabbed the surface of certain things. So let's kind of look at some results from that. So from left to right, the far left image is my fingernails. This is an hour after using the bathroom and washing my hands. I washed my hands after using the bathroom. Okay? Normal soap, just regular bathroom soap. It wasn't even antibacterial, just, regular soap. And then waited an hour, then swabbed my fingernails, and this is what grew. But even after I swabbed them, I didn't rewash my hands. Sometimes I bite my fingernails. I picked up some cookies, ate the cookies, even a peanut butter jelly sandwich. Oh, I had some jelly on my fingers, licked my fingers, licked my fingernails. Didn't get sick. Even with that much bacteria and growth of, who knows, I could have been at some store or something that had some type of virus going on, and maybe some of those have replicating viruses inside. Who knows? The next, let's see. The next one is the 3D printed mask that was left out for 3 months on the table. The next was my washed shirt, and after I washed it, I went to the store for an hour, came back, did a few other things, and then swabbed my shirt, and this is what grew on it. Fun fact, there's at least 10 deadly pathogens on there, including staph, strep, pneumonia, and some things that were carrying viruses, and I didn't get sick from any of it. And fun fact is, most of those actually live in your throat. It's because your body knows how to keep them in check. We have strep constantly living in our throat. We have pneumonia. We have staph. We have all of these bacteria constantly living on us, but our body keeps it in check. And so and it keeps them below the infectious disease number. So it's only when it gets to a certain point is when it becomes a problem. Especially if you have a compromised immune system, then that gets into a whole different thing. But we're not going to go there on this. Okay. Then the very last one is a metal spoon that was washed a few days before, and it was sitting in the drawer, ready to be used for ice cream, cereal, soup, whatever. And that's what it looked like after it had been washed and sitting in the drawer for a few days. Okay, so then here comes the fun stuff. After washing the side of the mask with rubbing alcohol, and you have to use agitation for rubbing alcohol to work, I swabbed that side and let it cultured. And that's the first picture on the left. Then I submerged the entire mask, washed it with soapy water, but I remembered what side I swabbed the second time, and that's the side I swabbed for the soapy water test. And that's what grew in the middle picture. You can see that the colonies are smaller, more spread out, and it turns out there's a little less bacteria formation or pathogen formation with the soapy water than the rubbing alcohol. I was kind of surprised, but they're very, very similar. And then the very last one is the metal spoon washed with regular Dawn dish soap and warm water. I think about 125 degrees Fahrenheit is what I used for the mask and the spoon. So not like really hot where it hurts your hands, but it's warm, feels comfortable. So you can see not a lot grew. They're kind of average. The rubbing alcohol on the mask compared to the spoon, and then the soapy water on the mask compared to the spoon. So, and I ate off that spoon. So, yeah, kind of goes to show that you can sanitize 3D printed parts. And the reason why is because even with the layers and gaps in the layers, or any types of dimples or surface imperfections. Remember, surface tension of soapy water is extremely low, and so is rubbing alcohol. It can get into pores as small as viruses. And that's why these were so clean, because soapy water does its job. So you can sanitize 3D printed parts, but that doesn't prove it's food safe yet. It just proves that you can sanitize them based off of the reasons for surface tension and off of the preliminary testing with the swab testing I did. And if you do smooth out, so if you take a 3D printed object like something with PLA, if you put resin around it, like that you'd 3D print with resin, a UV resin, and let it cure and it's smooth, you actually get less growth, or about the same. It's not necessarily like a lot less. It is less, but there's still growth. And we're thinking it has something to do with biofilms, which I'll get into here in a minute. But if you vapor smooth ABS, you still get low amount of bacterial growth. You'll get a little bit, but not a lot. It's about the same as this. I mean, things still grow on the surface. My spoon is a lot smoother, we hope, than a 3D printed part, even that's been vapor smooth. A glass tile, after it had been washed and just sitting, not a tile, sorry, a glass bowl, after it was sitting in the cupboard, still showed bacterial growth on it. So, because bacteria is ubiquitous, it's gonna grow. It's just how much is going to grow, and you have to get enough of that colony of bacteria to get sick. So, this has all been real science. This isn't any fake science. This is all real stuff. And if you need to question the validity of it, go find a microbiology book. You can get microbiology books free online. You can even take a microbiology course free online, which I find very handy. So I think that's pretty cool. Here's some SEM images. This is what a lot of people like to see. They like to see this kind of stuff. SEM is scanning electron microscope. The metal spoon I took with a regular digital microscope, so it's in color so we can see it, because it was a little bit harder in the SEM, because in order for it to work you have to cut a sample off, and I didn't have the ability to cut a metal spoon at the time, but it zoomed into the same 100, 100 microns zoomed in so that we can see things. So on the left obviously is the spoon, and you can see right here there's a surface crack. Okay, you've got all these scratches right here, then we got these massive holes in the spoon. No idea how they got there, and it looks just like a cutting board. I mean, these gaps right here, this is 100 microns from here to here, which means this is about 8 microns wide. And this surface pore, it doesn't go all the way through, they're just dimples, is about 3 microns. And this section right here, this is a solid section. This is a cross section of a single wall. It's solid all the way through. And then it creates these cusps. These are the layer gaps that everyone is concerned about, which they should be concerned about. I mean, it's valid to be concerned about bacterial growth in here. However, with the swab test, we have proven that it does clean. But we want to take it a step further, and that's what we're in the process of doing, is trying to stress the bacteria to grow a biofilm. Now, what a biofilm is when you stress certain bacterias, they throw a protective blanket or a shield over them. And it gives them food, nutrition, it protects them from sunlight and UV light. It also protects them against antibiotics and also antibacterial cleaning agents. And luckily, the foodborne illnesses that we're dealing with in the food contaminants don't produce biofilms, but we want to test against them. So you have to culture these bacteria, and that's what I'm doing here. There's 10 very dangerous bacteria right here. I'm culturing strep, staph, Pseudomonas, which is a really bad respiratory bacterial infection that makes it so you can't cough up mucus, and it doesn't bring up mucus, so you could technically drown in your own fluids. Kind of a scary death. I'm also doing E. coli, and there's about 6 other ones. I don't remember all their names. I can get the list. And so we're culturing them, and Pseudomonas is the one that's going to have the biofilm, and we're going to put it on the 3D printed part, and we want it to get into the cusp, and then we want to stress it out and see if we can get that biofilm to form, and then we're going to scrub it with soapy water on one of them, and then scrub it with rubbing alcohol, and soak the other one in bleach water, and then do tests to see if it got rid of the biofilm. One thing I wanted to discuss on this picture is this is no different than a cutting board that people use, a wooden cutting board or even a food safe plastic one. It gets knife grooves, but yet you can clean those and use them again and we're fine. Exact same concept. A 3D printed part is just like a corrugated cutting board, so you can sanitize them, and we're just trying to prove that we can get rid of the biofilm. That is a really important part. And then after we do that, we're going to test for contaminants like lead contamination. If you use a regular brass nozzle, how much lead's getting in your 3D printed part? Also, are the colorants, the binders and the glues in there, they're not labeled as food safe, but is it a toxic amount, or is it far, far below the toxicity that it doesn't matter? So that is the last few steps I'm taking with this project. We have not finished yet. We're still testing the biofilm portion. And when we do this, we do everything under the flame. And what that means is you can see the picture of the Bunsen burner in every single one of these pictures, because what it does is as this flame goes up, it pushes and pulls contaminants out of the way, because I have these petri dishes all around that you don't want just people walking around who are breathing, and it's just, you don't want their contaminants landing on this, so the flame helps push it out. And notice I'm just wearing a basic mask and gloves when I'm dealing with the top 10 very dangerous pathogens. I mean, I should be wearing eye protection, so that's a good catch. I should be wearing eye protection in that, because I would not want some of these things in my eye. And I always have to remember the flame is. There was a time when I kept smelling burning hot dogs, and I kept telling one of my colleagues, it's like, dude, I smell burning hot dogs. He's like, yeah, I can too. Where's it coming from? Didn't realize that I kept bending over to find something, and the flame was singeing my bangs. So you got to be careful when you do these things. You can light yourself on fire, literally. So, anyways, that is currently where we're at with all of this, and stay tuned for the next set of videos. It's probably going to be another 2 or 3 as we finish up. So thank you for watching. As usual, you can visit these 2 websites and find out more information about what I do and some of the other projects. So stay tuned for the other set of videos. I think it's going to be the Monday before Thanksgiving of 2021 that we're going to go back to the scanning electron microscope and look at the bacteria and the biofilms, and then we're going to try to clean the biofilms and then go back to the imaging, and we're going to start trying to prove, and then we're going to look at contaminants and go from there. So again, thank you for watching. I'm very grateful I've had the opportunity to do this over the last year to really help the community out, and I hope this just goes somewhat viral so that people can get the correct information. So, as usual, all my videos are just going to be about real science and the scientific method and how everything works. That's where I'm going to keep it. Thank you for watching, and I'm glad that you guys have an interest in my internship and projects. It's been really fun, and I'm grateful for my school for helping me out with this and all my colleagues. So again, be safe and have an amazing holiday season.